Alright, let's get started with today's LeetCode problems. Our first problem of the day is going to be LeetCode number 328, odd even linked list. Given the head of a singly linked list, group all the nodes with odd indices together followed by the nodes with even indices and return the reordered list. The first node is considered odd, the second node is considered even, and so on. You must solve the problem in O of 1 extra space complexity and O of n time complexity. Okay, so it seems like we just essentially want to swap the nodes. Okay, so in that case, let me just think about this. So we probably will, considering that it's O1 space and ON time, this probably implies a two-pointers solution, something of the sort. And let's see, suppose we had a runner pointer. Regular pointer. So runner pointer starts as head next. Regular pointer starts as head. Let's see if we could have the possibility of, we could have 0 or 1 if 0 or 1 nodes just return the head. No, or actually 0, 1, or 2 nodes return the head. So 0 nodes is 0 or 1 nodes is no change. 2 nodes is already organized because we want the odd nodes behind the even nodes, right? We want the odd nodes together followed by the nodes with even indices, right? And the first node is considered odd, the second node is even, so technically one indexing to a certain extent, but that's besides the point. So if we have 2 nodes, then the first one is odd, the second one is even, we don't need to change anything. So really the problem starts when we, the minimum problem is when we have 3 nodes. We have 1, 2, 3 essentially. So the idea is that if we start the runner at the head next, regular at head, we can say while the runner is not, the runner is next maybe, is not null. Or maybe while runner itself is not null. What would we do? Let me think. We want to move the right pointer, or we want to move the runners next to be the regulars next. We want to move the regulars, and we want to remove the runner. So we want to move this 3, or this 1. So the runner, or regular would be here, runner would be here. Regulars next wants to be 3. Then what do we want to do with the 2? So when we move the runners next to be the regulars next, that's fine. Maybe we move the regulars next here. Or sorry, so set regulars next to equal to runners next. So 1's next becomes 3. And then set the regulars next, which is now runners next, equal to runner. So the idea is that we move one's next to 3. 3's next to 2. And then move the runner forward twice and the regular once. Let me think. If we had 1, 2, 3, 2, 3, 4, 5. If we moved the runners, so let's set the regulars next. So we'll do regular here, runner here. So where r is equal to regular, r is equal to runner. Then we set regulars next to runners next. So 3. 4, 5, 2, r is equal to 2. Right, so we've essentially disconnected this to the graph, or from the graph. Though technically, yeah, 1's next now becomes 3. 3's next is 4, and 4's next 5. So we've set the regulars next to the runners next, which is 3. Then when we set the regulars next, I think I want to do I want to basically swap them? Yeah, maybe. Use a temp val to hold reference to runners next. Actually, we want to start it after, right? We want to start it not at 1, but at the 2. So in that case, this will start at head next next, regular at head next. And then what we do is we basically want to swap this around. No, we want to start it at head because we need that previous pointer, right? Start at head because of ref to the previous. This is runners next next. So the runners next next would be the 3. Then we want to set the regulars next to temp next. So we want to set the 2's next to 4. So if we did that, temp is equal to 4, right? Or sorry, 3. Runners next next. Oh no. So now we want to set this to 1 goes to 2 goes to we probably want to do this later on. So we want to start by setting the regulars next to the runners next, which is 3, 4, 5. Then we have 2 that really points to 3 still. and temp is still 4. Then we want to set the runners next. Sorry. So we set the regulars next to the runners next. Then we set the maybe we want to hold on to 3 instead, because the runner is here. Then when we set temp next to runner, set runner next to temp next. Actually, I want to do this first and then do this. So 3, 4, 5, and then this sets to like that. So set the runners next to the temp next. So 1 sets to 3. Then the runner next, so 2 sets to regular next to runners next. So 1's next is set to 3. Then the runners next, which is 2, is set to temp next, which is 4. Then temp next to runner, no. Yeah, actually, temp next to runner. So now we do 1R, 3, 2, runner, 4, 5. And then we're fine with that. Then do we want to just move the runner and the regular forward? So in that case, so end of first iteration, then we have 1, 3, 2, 4, 5 with the runner here and the regular there. And then we want the temp value to be equal to 2. We want to set 1's next to runner's next, which is 5. Then we have 2 and 4, which is a runner. Then we want to, so we set our temp val. We set our runner's next, which is 3 to 5, which is our runner's next. Then we want to set our runners next to temp next. So 1, 3, 5, 2, 4, which is our runner. Our runners next to temp next, which is 4, which is also our runner. So in this case, if same node may be null, and then we want to set our temp next to runner, which it already is. Oh no, temp next is runner's next, which is 5. Then Then we set the regulars next to the runners next, which is fine. Set the runner next to temp next. Which it already is. So 4's next is now null. And then set temp next. So 5's next to runner, which is 4. And then we lose the 2. How can we fix this? What if we hold a reference to the head of the even list, which is what we keep? So we say hold a reference to the even list head, and then we have the idea then is then rather than setting the temp next to runner, we set the temp next to even list head, which is initialized as runner. Right, because that will be the head of our even list. But we still want to maintain a runner. So let's continue. Let's do a bigger example. So let's do the 2, 1, 3, 5, 6, 4, 7, where regular starts off here, runner starts off at the 1. The temp is initialized to the runner's next, which is 3. The even list head is set to 1. Then we want to set the regulars next to the runners next. So 3, 5, and so on. Then we have a reference to our 1, which still contains a next of 3. Then we set our runners next to temp next. So we set 2, 3, 5, and so on. But our runners next is now 3's next, which is 5. Then we set our temp next, which is 3, to our even list head. So our even list head is 1, 5, and so on. So that is unaffected. Then we go to round 2. Two, 3. This is the runner. 1, 5, 6, 4, 7. Temp is going to be equal to runners next, which is 6. ELH does not change, the even list head does not change. So now we want to set our 3s next to 6. And then we want to set, that means we lose this 1 and 5. Then we want to move our runners next to temp next, which is 6's next, which is 4. Then we want to move the temp next to even list head. So 6's next is now 1. And then we can go for round 3. Where we have 2, 3, 6. 6 is now our runner. 1, 5, 4, or 6 is now our regular. And then we set our temp to 7. We set our 6's next to 7. And then we set our, we basically split our array. Then we set our next arrays, our runners next to temp next, which in this case is null. Then we set our temp next to the head of our list. So 1, 5, 4. And then we move it one more time, and then at that point our runner is done, and then we can return. Okay, so this seems pretty sound. So let's go ahead and code it up. This will run in O of n time and O of 1 space because we're not really manipulating anything that would exceed the size of our array. So let's go ahead and say if head is equal to null, or head dot next is equal to null, or head dot next is null, we just return head. So we don't care if 0, 1, or 2 nodes exist. We only care if 3 nodes exist. So we have a head, we have, or if we don't have a head, if we have a head but no head next, or if we have a head and a head next, but we don't have a head next. Then we can say var, we can say runner is equal to head next, var regular is equal to head, var, or actually val left even list head is equal to runner. And then we can say while runner is not null, we say temp val is equal to runner.next. We say regular.next is equal to runner.next. Or temp. Then runner.next is equal to temp.next. And we don't know if that's null or not, so and then temp next is equal to even list head, And then runner is equal to runner.next. Regular is equal to regular.next. And then at the end, we return head. So this goes through our steps that we initialize a temp value to hold the reference to the runner's next. Then we set our regular next to that runner next. So for example here, our 6, we set our value to our runner's next, which is 7. Then we set our runner's next to our temp next. And then we set our temp next to our even list head. And then we move the pointers along. So this seems correct. This seems to follow our algorithm. Let's go ahead and run it, and let's see if there are any issues. There may be some compiler issues about nullability. We'll see. Okay, looks like it worked for the first one. Let's try with the other example. Okay, looks like it worked. Let's go ahead and throw in a submit and let's see where we end up. Or if we have any issues. Looks like we ran into some issues here. Let me see. Looks like we might have an issue with even. Do you have an issue with even sized lists? Seems like we do. Let's take a look at why. If we have the runner here, regular here, runner here, and our temp is equal to 3, then we set 1 next to 3 to our 4. Then we set the runners next to temp next, so no effect. Then we set the temp next to our even list head. And then we move forward. Maybe it's our second round that's causing issues. If, let's see, 3, if we're setting our 3s next, okay. So while runner is not null and runner dot next is not null either, I think we're just accidentally setting this to null, and that's why we're having issues. Let's throw in a submit again then. Cool. Alright, seems like it's fast enough. It's pretty much the standard solution from the speed look of things. In any case, this was a pretty standard two-pointer solution. Seems like linked lists are very, very conducive to two-pointer solutions. Whether it's a runner node and a slower node, or if it's a node that runs twice as fast as a regular node, seems like it's mostly two-pointers for when it comes to linked lists. So I feel a lot more comfortable in this sort of area, which is why the solution didn't end up being anything, I don't think, too spectacular, but hey, it works. It runs in O of n time, it runs in O of 1 space. We did our part. In any case, I hope you learned something, and I'll see you for the next problem.